Hello, this is Dr. Donna Burnett. In this lesson, we will discuss cereal grains and pastas. Let's get started. By the end of this chapter, you should be able to draw the various parts of a grain's composition, list the foods made possible with cereal grains, summarize the main grains containing gluten, briefly explain the gluten-free grains, discuss the moist heat preparation of grains, explain how grains are stored, define the various types of pasta, demonstrate how to prepare pasta, and list the best methods of storing pasta. Cereal derives its name from the Roman goddess of agriculture, Ceres. Also from the verb creare, that is, to create. The word cereal refers to grains in general, seeds from the grass family Gramineae. The edible portion of the plant is known as the grain, kernel, or berry. In many ways, this is the staff of life. Grains are the world's major food crops. The most common grains are corn, rice, and wheat, which constitutes 90% of the world's production of grains. The remaining 16% comprises barley, sorghum, millets, oats, and rye. Figure 17.1 shows several of the many varieties of grains. We see corn, basmati rice, wheat, barley, millet, and oats. Figure 17-2 shows the most common cereal crops and their contribution to world grain production. You'll notice that corn is the greatest category, 37%. Then rice and wheat are almost tied, and then the remaining barley, sorghum, millet, oats, and rye. Each caryopsis has a protective outer husk, which is also called the chaff, which is not consumed. It protects the grain. The bran is where you'll find fiber and minerals. The starchy endosperm contains all of the grain starch, and then the cereal germ contains the embryo, fat, B vitamins, vitamin E, and spoils. And here you see a diagram in 17-3 that shows you the structure of grains with each of those components. And again, just to review the composition of cereal grains, take a good look at that diagram. There are some food additives that go into grain products. Fat-soluble vitamins can be added to the dough before baking. B vitamins and vitamin C is sprayed on the cereal after heating. Vitamin C is not stable to heat. BHA and BHT are added to preserve freshness. Cereal grains are used in quite a few ways. We have the flour of the grain, which is obtained from crushing the endosperm. It's used to make pasta, breakfast cereal, alcoholic beverages, and animal feed. The nutrient content of grains, in general, a cup of cooked cereal, pasta, or grain contains 160 calories approximately, 30 grams of carbohydrate, 6 grams of protein, some vitamins and minerals, and a trace of fat, as well as dietary fiber. Now, as far as the fiber content, that will depend on the level of processing. Whole grains are intact, ground, cracked, or flaked kernel. We have whole wheat or whole grain flour, bulgur, which is cracked wheat, oatmeal, whole cornmeal, brown rice, and less common you'll see arameth, buckwheat, millet, quinoa, sorghum, and triticale. Moving on to refined grains, which would not have the degree of fiber, you have white flour, degermed cornmeal, white bread, and white rice. Most refined grains are enriched and have added back after processing thiamine, riboflavin, niacin, folic acid, iron, but the fiber is not replaced. So you need to know the difference in enriched and fortified in general. Enriched means to add back what you took out from processing. Fortified, you add additional nutrients. Cereal grains containing gluten are going to be, you're going to have wheat, which most wheat is produced by Russia, then the United States. 75% of the wheat is harvested, is made into flour, and 25% is used for cereals, pasta, animal feed, wheat germ, and wheat germ oil. Wheat is classified by growing season, color, species, and/or texture. There are 14 species of wheat and over 30,000 varieties. Only 3 species account for 90% of wheat that's grown worldwide. That would be common wheat, club wheat, and durum. Here is an illustration in figure 17.5 of the 3 most common types of wheat. We'll discuss more about the differences in the wheat that have to do with protein content in additional slides. There are various forms of wheat that are marketed: wheat berries, rolled wheat, cracked wheat, bulgur, farina, wheat germ, and wheat bran. Barley is another cereal grain that contains gluten. Forms of barley would be hulled barley, pot barley, pearled barley, flaked barley, barley grits, and malt. Oats also would fall under this category of containing gluten, mostly because you can't guarantee that the oats would not have gluten, especially if they are harvested in close proximity to wheat. Forms of oats would be oat groats, steel cut oats, rolled oats, and oat bran. Illustration in 17-6 shows the varieties of oats. And here you see there's quite a bit of difference in the appearance, and it's dependent on how it's processed. Rye is another cereal grain considered containing gluten. Rye is second only to wheat as a grain used in bread making. You don't see rye bread as popular in all regions of the country as you do in the Northeast. Rye contains less protein than wheat. Triticale is also considered containing gluten. It is relatively new as a hybrid. It was developed by a botanist who crossed wheat with rye. It has a higher protein content and more of the essential amino acid lysine than wheat. Now let's talk about gluten-free grains. Aramath is high in protein. It can be popped like popcorn in a dry frying pan. Buckwheat is considered a gluten-free cereal grain. It's not related to wheat at all. It's not a true grain. It's the fruit of a leafy plant related to rhubarb. It can be used as a flour and cereal. It has a nut-like flavor. It's used in pancake flour and some breakfast cereals and crepes. Chia seeds are another gluten-free cereal grain. These are similar to tapioca balls in the ability to absorb water, expand, and become gel-like. Chia seeds are high in omega-3 fatty acids, and they may promote weight loss and blood glucose control. Now let's talk about corn. Corn is classified as dent corn, flint corn, popcorn, sweet corn, flour corn, and pod corn. Here in Table 17-1, you see a recap of the gluten-free grains: amaranth, buckwheat, corn, millet, quinoa, rice, sorghum, and teff. And in 17-7, you see corn, and it is classified by its kernel type. You see dent corn on the far left, flint corn, next popcorn, and then sweet corn. The bulk of U.S. grown corn is used for livestock. The rest is used for ethanol, human food, and seed. The forms of corn would be corn on the cob or kernel corn, hominy or hominy grits, and you see those in 17-8, cornstarch, corn syrup, and corn oil. Quinoa is a pseudo cereal because it's not a member of the grass family. It's technically a fruit and a staple of the Andean culture. It's higher in amino acid lysine than wheat and popular among vegetarians. Indian ricegrass is also a gluten-free cereal grain. Montina flour is produced by grinding this gluten-free grain. Then we have millet, which grows wild in Africa. It's one of the world's first cultivated grains and one of the smallest cereal grains. It's used to make unleavened bread and beer. Over half the world's population relies on rice, and 94% of the world's rice is produced in Asia. Rice is classified according to mode of cultivation, grain length, and texture. We have short grain rice, medium grain, and long grain rice. It's classified by the length and width ratio of the grain. In figure 1711, you see the sticky starch of short grain rice. The forms of rice, we have white rice, converted rice, instant rice, brown rice, black rice, which is purple forbidden rice, red rice, glutinous rice, specialty rice, and rice bran, and wild rice, which is from a reed-like plant. Sorghum is the cereal grain of major importance in Africa and certain parts of Asia. It's consumed as porridge, alcoholic beverages, or livestock feed. Its cushiony puffed grains can be used as biodegradable packing material. So let's talk about preparing cereal grains. In its natural form, you really can't even digest it. When you cook grains, you gelatinize the starch, improve the flavor, and soften the texture. The results will be achieved by moist heat methods, boiling, simmering, microwaving, and baking in the presence of liquid. So let's talk a little bit more about these preparation methods. We know from previous lectures that moist heat preparation is going to involve water, and the grains would either be boiled or simmered, but you first want to rinse the grains thoroughly. And as you cook the grain takes on the liquid, whether it's water or broth. It could be a flavorful broth or liquid that will enhance the flavor, but also can just be water. And the grain absorbs the liquid as it gelatinizes. The way you determine the doneness is basically by taste to see if it's tender. Rice has different cooking times depending on the type of grain. It will need to stand for at least 10 to 15 minutes to fully absorb the liquid. Let's talk for a minute about the preparation of cereal grains. Table 17-2 shows you the recommended liquid quantity and the heating times for grain preparation. In each case, you start with a half cup uncooked grain. You're going to add a various amount of liquid depending on what grain it is, and then your cooking time can be drastically different. So always it will yield more than you start with because you're introducing liquid, the grain will absorb it and take on a greater volume. So let's take a look at a couple of these. I think it's interesting, to me it's interesting that even in the rice category, the cooking time can be different, the yield is different. Let's compare basmati rice, a half cup uncooked plus a half cup liquid, cook for 15 minutes, and it yields 2 cups of rice. Compared to jasmine rice, where you start with a half cup uncooked, you add 1 cup of liquid, cook for about the same time, a little bit longer, and you yield 1 3/4 cup. So the volume is different, the cooking times are different, the amount of liquid you use to compared to the 1/2 uncooked grain are different, and which is why we need to follow the cooking directions on the rice or use a chart like this if you don't have those directions. We continue with barley, corn, oats, rye, and buckwheat. Some of you may have had some experience preparing grits or oatmeal, and you may have even prepared rice pilaf, which involves sauteing and then baking. You also can microwave grains. The heating time is not significantly reduced from cooking on top of the stove, but it is ideal for instant hot cereals. We want to store grains in a cool, dry place in an airtight container. This will keep out bugs and preserve the grains for as long as possible. Or you can refrigerate whole or cooked grains in an airtight container, but you would only want to freeze cooked grains. Let's talk about pasta. The Chinese developed noodles in approximately 5000 BC. Marco Polo was credited with introducing pasta to the Europeans in the late 1200s. Pasta is usually made from semolina, flour derived from durum wheat. The protein content of durum wheat makes it ideal for pressures of mechanical kneading and manipulation. We'll learn in another lecture about developing the gluten, which is the protein in the wheat, and also the different types of flours and which ones have the most protein and what you use for various recipes. That will come in the flour lecture. But I'll give you a little preview. We have soft wheat and hard wheat. Hard wheat is used for bread making. It's more protein, more structure, and it's also tougher versus soft wheat, which we would use for cake flour because we want a tender crumb in our cakes. So we're using higher protein wheat for pasta because we want the structure, we want the shape. Figure 17-12 shows a variety of pasta shapes and sizes. We do want to use the higher protein wheat for pasta because we need it to hold its shape. And here on the left, you see a list of the types of pasta. Figure 17-13 shows the three major sizes of couscous, and it varies by region. If you haven't tried couscous, it's quite delicious and easy to prepare. 17-14 shows prepared couscous, and in this case, the recipe called for some vegetables, tomatoes, red onion, other vegetables. You can find a variety of recipes using couscous. Figure 17-15 shows how we prepare pasta. In the first image, you see a large heavy pot where we're bringing 4 quarts of water to a boil for each pound of pasta. You might wonder, why do we need so much water? This is so the starch in the grain will fully gelatinize. For long pasta, you can add it to boiling water in batches. And if you push it down while you are adding it to the boiling water, it will soften so you can fit it all in the pot without having to break it. If it's a short pasta, you can add it all at once. Then you want to stir to separate the pasta pieces, cover, return to a boil, and then immediately remove the lid. You want to stir gently while cooking to prevent pieces from sticking together. And then in figure 4, you see the cooked pasta. You want to cook it until tender but slightly firm, which we call al dente. Taste to test doneness. Drain the pasta, but do not rinse because starchy surface holds sauce better. Here's a good example of how much pasta you would cook for a 1 cup serving. This would be the amount of dried pasta. So for short pasta, you want to use 2 ounces of uncooked or just over a ½ cup. For long pasta, you still want to use the 2 ounces uncooked, but in this case, you would pick it up in a bunch and estimate a ½ inch diameter. This is for each 1 cup serving. When we store pasta, we want to store it tightly wrapped in a cool, dry place if it's dried pasta. If it's fresh pasta, you can store it in a freezer for up to a month. If it comes in a modified atmosphere packaging, you can store it for up to 120 days, but you do increase the risk of microbial contamination. If it's fresh Asian noodles, you can keep it in the refrigerator for up to 2 days. And if it's cooked pasta, you can refrigerate it for 2 to 3 days and then reheat it in the microwave or in boiling water. Let's review. Cereal grains are seeds from the grass family. They serve as the world's major food crop and are known as the staff of life. We need to be knowledgeable about the composition of cereal grains, the uses, types, preparation, and storage of cereal grains, and the types, preparation, and storage of pasta. In this lesson, we talked about the various parts of a grain's composition. We listed foods that are made possible with cereal grains. We summarized the main grains containing gluten and briefly explained the gluten-free grains. We discussed the moist heat preparation of grains and explained how grains are stored. We defined the various types of pasta and demonstrated how to prepare pasta. And we listed the best methods of storing pasta. This concludes the lecture. See you in the next lecture.